This last example has a little bit of a trick to it that we're going to have to kind of understand, and I'm going to go through that little trick with you on the side. But all it really deals with is basic measurement, and we're going to go through how do we do that with basic measurement here. So we're told that a rectangle is shown which has a length that is 3 more than twice the width. So the length is 2w plus 3. The width is just the width. So width right here represents w. And so the length is some sort of related to width. So the bigger the width gets, the bigger the length will be. The smaller the width is, the smaller the length will be. And so what we're going to be doing here is we want to determine the dimensions that will give a total area of 44 meters. Okay. Now we're looking for a very specific one, and so x is going to be our width of that is going to equal the width of the rectangle, and y is going to be the area of the triangle. Okay, it's going to be the area. Now we know that area, and this little side note here, is length times width, or LW. And if we're given the information here on the screen, I'm trying to point to the screen, you guys can't see me point to the screen, so I'm sorry about that. Our area is equal to the length, which is 2w plus 3 times the width. Okay, so this is how we can find the area, and so I'm just kind of creating a bit of an equation that we can use to find our total area. Now if we multiply this together, we're going to get area is equal to 2w squared plus 3w. That's going to be, if we multiply these two pieces together, this is going to be our area, and this is a quadratic. Now again, area is y and width is going to be x. So our equation that we're going to have here is y is equal to 2x squared plus 3x. That's going to be the equation that we're going to use. Now we had to create that equation using some of the knowledge that we have, as well as the piece of information that we had as well. Now, our domain and range we'll get to in a little bit. We need to come up with our graph first. So let's go to Desmos. And again, we're going to create a new graph. Let's really do this beforehand. And y is equal to 2x squared plus 3x. This is what we're told. All right, so here's our graph. Now you'll notice these are our points. First things first, we cannot have a negative width. Okay, you can't have a box that has a negative width. That just does not work. Sorry, I just open this up a little bit here. So we know that x has to be greater than 0. So any of these, or that one will work, but any of these ones are not going to work. Okay, so we can't be using that. But we'll kind of move on from there. Our question asks, what is the dimensions that will give it a total area of 44 meters squared? Well, y is our area. So let's look at when y equals 44. And that's going to be up a little bit. I'm going to make that to dash line again. Really quickly. There we go. Here's my dashed line, y equals 44. And there is a point where it crosses. So when our width, or x, is 4, our area will be 44. Okay? And we could figure out what our dimensions would be based on that as well. And really, this is all we have to do for this question. It's just asking for that. Now we're going to put in our x-axis as well, or sorry, our axis of symmetry, negative 0.75. So x equals negative 0.75. Whoops, 0.75, that makes a little difference. There we go. I'm going to put that in there. Axis of symmetry, and all of our other points, which really don't make much of a difference. It's really only this point that we are going to be using, but we need to show our intercepts as well as our vertex and our axis of symmetry. So take a new screenshot of this right here. And I'm gonna make sure I get everything. And I forgot something, didn't I? All right, you reminded me, thank you. X is the width of the rectangle, and Y is the area. And this is in meters squared, and this is in meters. It's good to have that in there as well. Now it's tough to see this as it's kind of right on the line, but that's okay. I can read it. It's important that we make sure we have everything in there. There's my points. And now we'll go back, take a new sketch of this because now I have those labeled. It'd be really tough to force you to do that if I didn't, wouldn't it? Copy this and let's put it into right here, make it a little smaller, make it not, there we go. All right, there's my graph. Okay, domain of this here, okay. Domain x has to be greater than 0. There, that's it, okay. That's all we need to put there, and the range y is also going to be greater than or equal to 0 because we're starting at that 0 point. So we're starting here and we're going up. We can't have a negative width, okay? So we can't go into the negatives. So we're just going to go in the positives, and then anything is possible as it keeps going up to infinity. Finally, let's answer the question. Okay, so in terms of the dimensions, the rectangle with a width of 4 meters and a length of, oh, we didn't find the length, right? Well, our length is just 2 times our width plus 3. So 2 times 4 plus 3 is 11. So it has a length of 11 meters. We'll have an area of 44 meters squared. And that's it. That's our question. That's our solution. We had to come up with the equation, which we plugged in here. Again, we switched out our area and our width for x and y as we had described here. We have our domain and we have our range. We have our answer to our questions, one simple question, and we have a graph which shows everything that's a part of that as well. So make sure all your graphs are labeled, make sure you are showing your work, make sure you are demonstrating how you came up with the answers and that you are coming up with the answers in complete sentences as